In this video, we'll be looking at straight lines and tangents to circles. This can all be found on page 216 of the Grade 12 Maths Handbook and Study Guide. So, we're going to be using a little bit of Grade 11 Euclidean geometry for this. And what we need to remember is that tangent to a circle is always perpendicular to the radius at the point of contact. So, in questions like this, you'll normally be given the point of contact, which would be an x and a y coordinate, and you'll normally be given the circle center, which we covered as A and B. So the general steps to finding the equation of a tangent to a circle, if the point of contact is given, is we find the gradient of the radius at the given point of contact. So we would find this gradient here, simply using the formula, gradient equals y2 minus y1 all over x2 minus x1. Those brackets actually aren't necessary. Once we've got that, we also know that perpendicular lines' gradients, when we multiply them together, are equal to minus 1. Or we can write it as the gradient of the radius is equal to the negative reciprocal of the gradient of the tangent. So if the gradient of the radius was equal to minus 3 over 2, the gradient of the tangent would be equal to positive 2 over 3. Once we've got the gradient of the tangent, we simply write the formula for the tangent as y is equal to mx plus c. We know m is gradient of tangent in this case, and that's y equals gradient of tangent x plus c, and then we simply substitute the point of contact in to solve for c. This will be much clearer in the next video when we cover example 1, which has actual figures on page 216 of the Maths Handbook and Study Guide for grade 12.